Welcome to our channel. In today's video, we'd like to share some thoughts on multi-tenant application database tenancy patterns. When designing a multi-tenant application, you must carefully choose the tenancy model that best fits the needs of your application. A tenancy model determines how each tenant's data is mapped to storage. Your choice of tenancy model impacts application design and management. Single tenancy, a simple and isolated model. Single tenancy pattern is very common for many simple or internal applications. Single tenancy means each database stores data from only one tenant. In this model, each instance of the app is a standalone instance, so it never interacts with any other standalone instance. Each instance of the app has only one tenant and therefore needs only one database. The tenant has the database all to itself. This model provides the greatest database isolation, application-level isolation. But the isolation requires that sufficient resources be allocated to each database to handle its peak loads. Multi-tenancy, efficient and scalable storage. In a multi-tenant architecture, each database stores data from multiple separate tenants with mechanisms to protect data privacy. There are two primary multi-tenancy patterns: multi-tenant app with database per tenant, multi-tenant app with multi-tenant databases, sharded, multi-tenant app with database per tenant. This pattern uses a multi-tenant application with many databases, all being single-tenant databases. A new database is provisioned for each new tenant. The application tier is scaled up vertically by adding more resources per node, or the app is scaled out horizontally by adding more nodes. A catalog is required, in which to maintain the mapping between tenants and databases. Usually a catalog is a shared database, which stores the mapping data regarding tenants and databases. Multi-tenant app with sharded, multi-tenant databases. This pattern stores many tenants in a multi-tenant database. The application instance can have any number of multi-tenant databases. The schema of a multi-tenant database must have one or more tenant identifier columns so that the data from any given tenant can be selectively retrieved. Further, the schema might require a few tables or columns that are used by only a subset of tenants. Sharding adds complexity both to the design and operational management. A catalog is required in which to maintain the mapping between tenants and databases. Choosing the right database tenancy model is essential for the success of a multi-tenant application. While single tenancy ensures isolation, multi-tenancy offers better scalability and cost efficiency. Each approach comes with trade-offs, and the best choice depends on application requirements, scalability needs, and operational complexity.